Okay, I explained the videos and how to be a nerd at the beginning, but in case you skipped it, this one's a little bit quicker than that last video, which is rather long. So, the table of contents. Now, I did this a long time ago, a year or two. I've been working on these videos for the last 8 years of my life, and I'm just putting them all together now. So, here's the table of contents. If you're at a different school and you're not using the public school black and purple books that kind of look like this, then this table of contents is really good for you because it allows you to see what chapter mine is for similar words and whatnot. So let me just quickly go over it. Okay, the clear sheet. So that is your formula sheet, and the boot camp in the video How to Be a Nerd. Hopefully you're going to put that into a clear sheet. Then we have what's called the staple. Now I hope you print this off and you staple it. It's a review from grade 11 and a few years before. Just some regular sheets that we're going to use. And again, this isn't correct. So if you print this table of contents off, it's just going to have similar sheets to this. All of the website table of contents is good because I've just done it, but this is just a table of contents, which I hadn't realized I'd updated, but I'm updating the website, so I'm just doing it unfinished right now. So then we have the duotang, or what's called formulas on the website, and that's this page. And methods and remembers and general equations and graphs and fractions and exponents review and algebra, and then sheet on each chapter, like transformations, or possibly 2 for chapter 1 and not 1 for chapter 2, and then 2 for chapter 3 and then 3 for chapter 4, etc. A chapter review for each sheet, which is, I will point out, if you are to print out this whole all formulas right now, then don't print the individual formulas for each chapter when you're going through the video. Just either watch the video and then start on the notes. But I'm just going through the first initial, but if you do want to print out a nice big formula package, do this one and print it out double-sided. Keep it with you everywhere you go. Maybe keep it with the staple. Do whatever you like. So now let's get into chapter 1 down at the bottom left, which is all the things that we can do in transformations. And I've really just written a lot of letters, and we really just need to know what V and H and C and E and R mean, and working on points and functions, etc. Chapter 2 is pretty short. We did a lot of chapter 2 in grade 11, so we didn't do a lot of that. Chapter 3, long division, synthetic division, factoring, polynomials, etc. Now we have 3 chapters of trigonometry and all the things we're going to do in trigonometry, etc. And graphing and trig identities. And exponent laws, chapter 7. And logarithms, chapter 8. And rationals, chapter 9. And composite and operations on functions, chapter 10. And combinatorics, chapter 11. And all the students who are going down to the States and want to learn a little bit about conics and parabolas and hyperbolas, I've included those notes, so feel free to print those. Okay, the next sheet is a year in pictures. So I'm going to circle these pictures in red. So transformations and radicals, moving graphs around, chapter 1 and chapter 2. Chapter 3, polynomials, x cubes, x to the 5s, and their funny looking monkey graphs. And then 3 chapters of trigonometry using special triangles in the unit circle and graphs and new identities that we've learned like secant. And then the top right, we're going to be doing exponents and exponentials with variables in the exponents. Excuse me. Then we're going to be talking about logarithms and exponential graphs, and we know they're inverses of each other, so they have very mirrored like graphs. And then we're going to talk about rational graphs and this form and the other form and all the rest. And then I have it in the wrong order, but we're going to do operations on functions and then work with these blanks. You know what? I'm actually not going to do that chapter. I'm going to leave it to you guys to print those notes, read them off, and maybe come and see me. So, as I mentioned before, I do a chapter review on each each one of the chapters with all the methods and things to remember. But then I also do a yearly review so that I can practice studying for final exams in university. So for example, I'll circle in red, Chapter 1, Transformations, and all the things I need to do. It's like a checklist. It's like a how well do I know these things. It's like a test myself. Then Chapter 2, Radicals, going down the page, and all the things that I do with radicals, square rooting things, picking points, square rooting the values. Chapter 3, Polynomials, and a big checklist of the things that I'm going to do. Trigonometry, and all the methods from trig. Again, each of the individual chapters has most of these methods and formulas and whatnot, but this is the yearly review, and it's a good practice starting early making a yearly review. Trig function, oh look, just the box model in DACB, because I did so much trig in the chapter before. Identities, remembering we're going to work with identities and do all those things. This box is actually the methods for the staple, which you can print off, etc. And it's the methods from grade 8 to 11 and just some of the regular things that we do, and quadratic formula, the program to write on your calculator, and regular graphs, and just things that apply to grade 12. And then in the top right, exponentials, and logarithms, and rational functions, and function operations, and combinatorics. Combinatorics is much more university. Most teachers will allow you to get into university, be all finished, and then just give you a side test that doesn't even count on combinatorics if they're nice. But it has much more bigger thinking pictures. And again, you can print off the review sheets for that chapter or the notes in the homework and read those, but I don't have videos for those. So on to the remember. Again, I have a methods sheet for the year and a remember sheet for the year. So the remember sheet for the year, I wrote down all of the English sentences in the first chapter from each and every page that had an English sentence on it and put them all in the same spot. And then I can now cross out the ones that I know really well and circle the ones that I need to know better. You probably can't even see this on mobile, but print off the notes and print off the appropriate sections before you're going to watch it, and maybe just listen to it at that point. Remembers on radicals, remembers on polynomials, remembers on trigonometry, 3 chapters of trigonometry. And off to the right, exponentials and logarithms and rationals and function operations. And you're not supposed to use my remembers as your remembers. You're supposed to use my remembers as a guide for the regular things that you're supposed to remember that you regularly forget as English sentences or formulas or little notes for you to remember, excuse me, and review often until they're ingrained. So that's the remember sheet. Now onto the general equations and graphs. In the top left, we have Math 10, y equals mx plus b. Then in grade 11, we looked at quadratics. And in chapter 3, we looked at cubics and quartics and quintics. In grade 11, we looked at absolute values. In grade 12, in chapter 2, we look at radical functions. And notice these are all the regular graphs and their regular equations and their domains and ranges and any important parts and rational functions. And our 3 trigonometric graphs that we're going to memorize, and exponential graphs and logarithmic graphs and their features. That must be a lot. Okay, fractions. So we need to be able to do all these fraction things. I'm not going to talk about them all. Adding fractions, multiplying fractions, dividing fractions, working with fractions equations, etc. Then all of our exponent laws. Gosh, memorize your exponent laws from grade 9 or 10. And how different rules don't apply to different things. And make sure you're really good at all your factoring. Trinomials, differences of squares, greatest common factor. Number of times we do it is phenomenal. Okay, so that's the end of the duotang. Or remember, either print or the formulas for the whole year. Print either this whole thing and don't print off the formulas from each chapter, because I've just decided to put it all in one place at the front here. A little bit more. So remember, print the notes, print the homework, print them all at once. Print them one at a time. Watch the videos on the notes. See if you can do the homework. Do your teacher's homework. Maybe do my stuff before you go to class if you have time. Ask teachers better questions. You're going to get way more out of class if you have a little bit of an introduction. Maybe watch my videos before you get into class. Remember, the sections aren't lined up. I've got like a 6.8 because I wanted to break stuff up differently. So, different authors want to do different things. I did it that way. So, again, print off as much as possible. Either watch with two windows side by side, or watch with one window on a tablet or a computer and print off and follow the notes and try and do the homework, or go on mobile and either just read the notes on mobile or watch the videos on YouTube. They're in vertical orientation specifically because we go down the page and it looks better. And have those notes out maybe on video when you're actually in class. Turn the volume down and just press play and see how it all works. A lot of it's good. My difference between Khan Academy and myself is the only one I'm going to mention, and that'll be the last of this review. He's just got videos. I have notes that you print off that you follow along the videos with the notes, so you don't have to follow writing every single thing. You can if you want, and you may get more out of it, but at least you have a backup. So when you can print off all of my homework, then you can just scan it and find out which questions are similar to the questions that you're doing in your homework. Then you know to watch the video off to the right of that button for the homework to see how to do a similar question. Print off the notes and look how to do similar questions to the notes and see how it applies to all your questions. I'm trying to have a bigger, wider variety of encompassing math. Notebooks, homework books, video. Please tell me what you think. We'll be upgrading all sorts of different stuff, possibly changing curriculums in the future. I know it's already happening. I'm going to have all sorts of problems. I know I will. Con has. I'm going to too. I'm going to try and have him reference my website, and I'm going to reference his. I'm going to talk to a bunch of teachers and try and see if they can implement the free math notes and homework online. And I really did it because I wanted more homework and notes online or in class. And the teachers either had it saved on some USB and it was difficult to get, or they drew on the whiteboard or whichever. And I wanted to provide a free, easy following layout. So when you're on the website and you hit a certain button, you can read the other types of titles. And you can print the notes and find out the section that you like is similar to the question you're working on, and then watch the video on that section. Maybe by the end you're just carrying the formula sheets around because you understand that the formula sheets represent all of the notes all together with all of the formulas and the things you need. But again, please give me feedback. We're always looking to update. We're going to be doing videos on the other grades and physics in the future. Feel free to roam the website. Physics 12 or Pre-Calculus 12 is the only one done right now. I think Pre-Calculus 11 will be second, then Calculus, then maybe Math 10, or Physics and Chemistry. So again, please tell me what you think. Please tell your friends. It's all free. Hopefully it will be as long as I can. I don't know how I've decided to work it out. Maybe Patreon, maybe ads. My gosh. Great. Thank you very much. Again, my name is Nicholas Craig. This is NAC Academics with 2 Ks, K-N-A-C-K. And our website is nacacademics.com. And our telephone number is 604-505-2867. That's all on our website. And if you ever want to get to the website really quickly or want a quick bookmark, it's knackclub.com, KNACK club.com, and it's a little bit quicker. So again, thank you very much. Please tell your teachers and your friends, and use it as you like. Okay, so we have skipped through all of the grade 12 versions of the cheat sheets because I've gone through each of those videos at the top of each chapter on the website. And now I'm just going to go through a few other sheets that I've just decided to include. I'm going to go through them a little bit faster. They are review. So last year we worked a lot on the parabola x squared. We did a lot with it. Graphed it, factored it, completed the square, etc. We did a lot of trigonometry, which we're going to repeat this year. We saw the graph 1 over x. We called them reciprocal functions. This year we're going to call them rational functions. We also saw the absolute value. That one will come up from time to time. We took a look at intersections between graphs, some inequalities, and sequences and series, arithmetic and geometric, and then a few radicals like squaring both sides. So now we'll take a look at some of the methods. So in radicals, all of the methods that we did in radicals. The biggest one we're probably going to do is the restriction set underneath the root, greater than or equal to 0, and solve. Jumping ahead off to the right, reciprocals in a big square. Another restriction, set the denominator can't equal to 0, and solve. We did a lot of work on quadratics off the left. Quadratics, huge. We graphed them, transformed them. We completed the square, used the graphing calculator, factored them, used the zero product principle, used the square root method, quadratic formula, and the discriminant. Down at the bottom there, we took a look at systems of equations and how we can either set two things equal to each other or add or subtract them, make them equal to 0, and find out the location of their x-intercepts. Be careful with both of those. It's kind of confusing. Top right, absolute values, positive case, negative case, piecewise functions. We do a lot more of that in calculus, piecewise functions. Reciprocals, again, now they're called rational functions. Vertical asymptotes, domain, invariant points. Off to the right, inequalities. Possibly graphing inequalities, not so much in pre-calculus 12. Rationals, so that's where they join up with what we call the reciprocals before those interesting graphs we talked about, and how to work on those, adding and subtracting and using the lowest common denominator. And then trigonometry, all of the same trigonometry in a new measure for degrees. It's going to be fun. Okay, all the things to remember. I'm going to overline it. Radicals, things that we can and cannot do. Quadratics, differences of squares versus square rooting both sides, and don't forget about plus, minus. We're going to be doing a lot of greatest common factors of -1. Beware of brackets. Subtract a binomial, brackets. Distribute. Add fractions, distribute. Some common mistakes. Got to make sure those are no longer. Top right, a little bit about inequalities and square rooting both sides with absolute value, but I'll let you do that theory on your own. And again, just trigonometry. There is a lot of trigonometry in grade 12. So some of the general graphs, we saw a linear equation in grade 10, and then we saw the quadratic in grade 11. This is the one that we're going to see called polynomials, x cubed, if anyone has ever tried to graph it for fun with a table of values. Absolute value functions, we saw these last year, the v, and we move those around. We'll be moving those around again. And then reciprocal functions, which again we're going to call rational functions. We're going to talk about vertical asymptotes, horizontal asymptotes, holes, etc. Getting prepared for calculus if necessary. A little bit more on the general graphs and their equations. Just a few examples of them. Print this off. Keep it with you if you like. Some regular calculator buttons. How to graph, how to find the vertex, how to find y-intercept, how to find x-intercept. A casual other way off to the right, how to find x-intercepts more easily. And how to find intersections between graphs. We'll be using these buttons the most on the graphing calculator. Sequences and series review. I've seen some talk about arithmetic sequences from grade 11 going into grade 10 and geometric going into grade 12. But all of the arithmetic formulas and all of the geometric formulas, we really want to understand geometric growth. All sorts of applications in business and science. Trigonometry review. It's going to be the same review that we are going to be doing in grade 12 with the new angle measure, something other than degrees, which I spoke about. So again, special triangles. We've got to memorize those guys, girls. The ASTC graph. SOHCAHTOA. The unit circle and the actual definition of sine, cosine, tangents. Again, the unit circle and the actual definition of sine, cosine, tangent. All the different quadrants. We're actually not going to be doing the sine law and the cosine law again this year unless you need to or you take physics or something. Still a lot of talk about the period, and we're going to be graphing these things more intensely this year, moving them around, seeing more applications to real life. So the trig summary. Sine is typically equal to a fraction where we can do special triangles, or sine or cos is equal to 0 or 1 where we use the unit circle, or it's equal to something that we cannot use special triangles or the unit circle for, so we have to do the inverse calculation. This should all be review. A little bit on where the special triangles came from. I go more into depth on this in our new angle measure in trigonometry, but an equilateral triangle with side lengths of 2 cut in half is the special triangle. A square cut in half with side lengths of 1 is the other special triangle. Do Pythagoras to figure out the other sides. A lot easier to learn things. You'll remember them for much longer. The ambiguous case of sine, that's not going to happen again, but it's there. So read it if you like. Graphing quadratics, so we're going to be seeing a ton of vertex, we're not going to be seeing vertex form. We're going to be seeing a ton of general form and factored form. And we're going to be looking at cubics. So there's no more interest in completing the squares or nice formulas for vertex. You have to either use your graphing calculator or learn calculus. So not much more of vertex form, but don't forget it. Lots of talk about opening up or down. X and Y intercepts. X and Y intercepts. Y intercepts. Set X equal to 0 and solve. X intercept. Set Y equal to 0 and solve. Domain, range, etc. The key points of the quadratic. So again, not much vertex form, but lots of standard form, lots of factored form. X intercepts, Y intercepts. A little bit on the vertex. And in the graph, X intercepts, the vertex, Y intercepts. A lot of standard form to factored form and foiling it out, but not too much on vertex form. Again, key points of a quadratic. When I change the a value in front, noticing it gets steeper. Solving quadratics, remember, factor any way you can. Try and remove a greatest common factor first. Then try and factor a quadratic if you can. A might be equal to 1 or not equal to 1, factoring trinomials. Lots of differences of squares. We're not going to use the quadratic formula too much, but we should remember it. And not too much completing the square and using the square root method at the bottom, not too much vertex form anymore. We're going to be looking at cubics. These are quadratics, and there's not a form for completing the cube. So lots of graphing with the table of values. If anyone ever asks how to graph something, yell out table of values. It's the only surefire way to graph anything ever in any university, high school, math, whichever. Again, lots of factoring and not too much of completing the square. We'll be using the quad form a little bit. Quadratic formula for your calculator. This is the program on the top right. If you can type it in without looking at the buttons, go nuts. Outside of that, this is a fairly good idea of the combinations of buttons. And again, remember at the top, big red, this is what it should look like after when you run the program. And this finds your x-intercepts for you, solving quadratics. Radical review, I mean a ton at the top with the definition of a square root, of a even exponent or odd exponent, and then some examples off to the right. I mean, review your adding and subtracting and multiplying and dividing of radicals. We're not going to be doing too much on it, but there is a chapter in the public school, a little bit more on exponents. Rationalizing the denominator, that's the thing that your teacher may or may not require you to do. Some examples off to the right, and just the definition of the conjugate, why we use it. Just a very interesting concept, so that's one to take more for calculus in the future, but you never know. Rationals review, so these are some methods that we did from a topic called reciprocals and rationals in grade 11, probably. And now it's called rationals, and we're doing the same thing, simplifying, adding and subtracting, and working on equations, multiplying both sides by the LCD, possibly, looking for x-intercepts, y-intercepts of rational functions. Common mistakes. Top right, we cannot do this. Just don't do it. You can't do it. If you did try, you just have to re-add and subtract fractions, and you're right back where you were. Top right, big red. Don't do it. Just don't. Can't do it. You can't divide the top and bottom by 4. You can't cross them off. There's no logic to it. Try and use logic. Can you divide the top and bottom by 4? No. You'd have to divide the 3 by 4. Do you want to do that? No. Then you just have to add fractions on the top and the bottom, and then you'd be back to the same place you were. So don't do that. Reciprocal steps, definitely. These steps were from last year, so if they ring a bell, it'll help you to graph rational functions. So with reciprocals from grade 11, we'll usually graph the original first. So I'm down below in big blue, like x minus 1, y-intercept of negative 1, and a x-intercept of 1, therefore. And the location of the vertical asymptote is exactly at the x-intercept of the original. So outside of that, definitely use the table of values, but we cannot divide by 0. So where the original was 0 is the location of the vertical asymptote. We're going to see lots of vertical asymptotes, and we'll see a few of these invariant points, points that don't change, points that are on both graphs. So after we do draw the reciprocal function from grade 11, which we're going to see a lot in rational functions, we want to be familiar with the shape. Vertical asymptotes, horizontal asymptotes, etc. The different reciprocal types that we saw in grade 11, you may or may not have seen all of these types, but multiple vertical asymptotes, no vertical asymptotes, x and y-intercepts possibly, horizontal asymptotes, etc. Let's jump to grade 10. So the pictures that we're going to have to remember from grade 10, lots of conversion factors. Just so much geometry and volume, trigonometry, radicals, simplifying radicals, etc. Working with polynomial functions and their degrees and their coefficients. Factoring these things all the time, all the different factoring types. And a little bit of y equals mx plus b. Still happens in calculus. Some of the methods. We're going to go a lot quicker now. We're in grade 10. Some of the methods. Your exponents. You just have to know your exponent laws. Just have to. Measurement, surface area, volume, factoring. All of your factoring types. Greatest common factor, a equals 1. Trinomials, a is not equal to 1. Differences of squares. Just so much trigonometry, domain and range. Graphing in all the forms. Slope point, general, y equals mx plus b. A lot of substitution and elimination of word problems. Setting up two equations and putting one into the other. So some remembers from grade 10. Your radical rules. Just know what you can do and know what you can't do. And again, exponents. Remember your exponents. This is going to be a review for methods. It's just going to happen. But polynomial mistakes, things you can do and cannot do. Things to remember in trigonometry. Think about the theory behind it. It took scientists hundreds of years, 1,000 years, 2,000, 5,000 years to figure these things out. It's incredible. We're standing on giants. Newton said that, and I'm standing on his shoulders. Linear relations, graphing, domain and range again, word problems, etc. Geometry review. These are the basics. Outside of, I'm just going to write them down, V equals 4/3 pi r cubed is the volume of a sphere. The surface area, interestingly enough, if I bring this 3 down and multiply it by my coefficient, 4/3, I get 4 pi, and if I subtract 1 from the exponent, I get r squared. So what's out of that one? They're all here. Area, length times width. Triangle, base times height divided by 2. Sorry, rectangle and square before. Circle, a equals pi r squared. And look at this. If I bring this 2 down in front, I get the formula for the circumference. Interesting, the relationship between the volume of a sphere and the surface area of a sphere and the area of a circle and the circumference of a circle, bringing down the exponent and subtracting 1. We'll see that later in calculus. Now for any prism, as long as the base is the same as the top, like a cylinder or a rectangular prism or a triangular prism, as long as the base is the same as the top, the formula for the volume is just area of the base times height. And the surface area is just lay all the sides flat and do all your formulas from above. Remember, the cone and the pyramid is just 1/3 of the thing above. So if you know the formula from above and you understand it, and then the cone and the pyramid are very simple. Don't forget about Pythagoras. You can't have a party without Pythagoras. And then the sphere ones, they'll usually give them to you. So no real need for a formula sheet. Memorize these basic concepts and you know them all. The trig summary, I can't stress this enough, how simple these concepts were and how many different combinations that they could have given you in trig to make it look difficult. But I mean, they're going to give you SOHCAHTOA, and then we decide on which SOHCAHTOA we're using. And then off to the right in big red, we either times those sides, or we technically cross multiply, or we do the inverse calculation. We're going to be doing a lot of trig in grade 12 and beyond. The exponents review, we just have to know these. I'm going to probably do this in grade 9 in a couple minutes, probably a minute. But adding, subtracting, multiplying your exponents, negative exponents, negative coefficients and brackets, and all of the things we need to memorize. We're going to be using this formula off to the right a ton. X to the 1/2 is the square root of x. We just have to understand that on a dime. The factoring review, grade 10, we'll be always removing a greatest common factor. And then factoring trinomials in any method you like, whether or not A is 1 or A is not 1. Or you can do the quick methods off to the right, but remember at the top, big red, don't forget to check by FOIL or distribution. That is the way to learn some of this on your own. Factoring differences of squares, lots of differences of squares. It's going to come up in trigonometry, etc. And then all of the special ones down below. And remember, sometimes we cannot factor. Don't forget that. So graphing review, obviously y equals mx plus b at the top. We're going to see the most. Don't forget, just use a table of values. If you forget everything, table of values. Slope, we only do slope in grade 10. And then we skip it, and then we do it again in calculus. So we're not going to talk too much about slope other than lines. Slope point form, again, not going to see it much until calculus. And general form of a linear function, again, not much until calculus. So the same exponents review with a little bit more detail from grade 9, but adding and subtracting, multiplying, negative exponents, negative coefficients in brackets, some things to remember, the theory on the things above, and some very interesting patterns that we just need to be able to do very, very quickly off to the right. And again, that little off to the right in the middle, that little radical fraction exponent pattern, that we will be using a ton in all different chapters. Algebraic expressions, not going to talk about this too much, but middle, bottom, right, adding and subtracting like terms, multiplying and dividing. We're going to be talking about middle, top, right. We're going to be talking about a little bit about the degree of the term and the degree of the polynomial, the leading term. But we'll talk about that more in polynomials. And then monomials, polynomials, trinomials, etc. And things at the bottom right that are not polynomials, because we're getting a lot of different things that are not. Grade 9 circles, not too much. These are just things that we have to just quickly know, like all of our parallel line laws and all of our circle rules. Not too much on polygons unless you're going to be doing foundations. A little bit about arcs off to the right. And then lots of triangles. Just lots and lots of triangles. The parallel lines review, as I mentioned before, but opposite angles are equal, angles on a line sum to 180, the Z rule, corresponding angles, and then a few other rules on that page. The grade 8, remember, I can't stress enough, know how to work the number line, multiplying and dividing, positive and negative numbers, equivalent fractions. We're going to use a ton in trigonometry. Nobody ever understands this is to this as something else is to something else. That concept is one of the beginnings of math. Seeing a pattern, applying that pattern to another similar thing. And one of the most basics is similar triangles. Percentages, decimals, fractions, just all the time. Knowing how to work with all of our equations, getting rid of denominators, multiplying by the LCD, geometry, square roots. Not much probability till university. They took it out of Pre-Calc 12, so we just brush up upon it, depending on your school. The remembers, multiplying and dividing, positives and negatives. Every number's over 1. Negative either belongs to the top, the middle, the bottom, or not both. A little bit of x's and coefficients and denominators and what things aren't equal to. Working down, a really quick version of grade 8 and just things that we need to remember and whatnot. Can't divide by 0. Gosh, can't divide by 0. Cannot divide by 0. 8 divided by 0 is undefined. Any number divided by 0 is undefined because we don't have a definition for the answer. Read this sheet. Really understand it. It helps. Here's that similar triangle that I was talking about earlier. If this double triangle and this bigger triangle and this smaller triangle are similar, well then 12 over 8 equals x over 4, or x over 12 equals 4 over 8, or any version that makes logical sense. Something is to something else as something is to something else. We're doing that a lot, especially in trigonometry. Just decimals. Gosh, being able to work with decimals and fractions, going back and forth between them. Percentages. Lots and lots of percentages, especially in exponentials, working a lot with money. Just fractions, adding, simplifying, multiplying, dividing, adding. Mixed fractions, not too much, but just really being able to be good at these things. Trigonometry, we all of a sudden start adding fractions, multiplying both sides by the LCD, etc. Solving linear equations, we're not going to be subtracting 1 from both sides anymore. I mean, we are, but the teacher's just going to start saying stuff like bring it over, where we just bring a positive 1 from one side and bring it over and call it a negative 1 on the other. Teachers are going to get lazier and lazier and lazier as you get on to university. Even though you don't like to do it that way, you want to do it these quicker methods because teachers are going to do it and you want to be able to follow it and not have to think for a moment, what did they just do? So add 1 to both sides, no more. Bring it over. Divide both sides, no more. Bring it over. Multiply to both sides. No more. Bring it over. Cross multiply. Excuse me. Times both sides. No, we're going to cross multiply. A couple more. So multiplying by the LCD, I'm just going to circle the title. And we're either going to get it at lowest common denominator, then multiply by it, or we're going to multiply by it, or we're going, instead of actually multiplying by it, we're going to multiply it and simplify it at the same time. Because this solution is much better than this solution. And the more and more you learn these advanced, simple methods, things are just going to come so much quicker in pre-calculus and calculus and whatnot, allowing you to do better in those courses and free up more time to do better in other courses. So one last sheet on adding and subtracting to both sides. So I guess in black, because most of this is colored. So instead of subtracting b from both sides and then crossing them off, etc., and it's showing up on the right hand side, I'm going to erase that step of crossing the b's off and subtracting them from both sides. And in red, I'm just going to cross off the positive b, and it's going to just show up on the right hand side. Think, subtract b from both sides. Do this. Now let's say down below I want to solve for a. Well, I know b is on the bottom, and I need to multiply both sides by b. b times b. And then I can cross them off on the left hand side. And then I'm left with exactly what you see below. Now instead of doing all that, I'm just simply going to cross off the b and put it up here next to the c. Called cross multiplication. I could also move the d up, but I don't have to. So many people learned that you had to. Just bring the b up. I'm going to erase that crossing off. I'm going to erase that b. Don't even have to cross it off. Just bring it up. What if I brought the b down? Well, what if I wanted to solve for c? I could bring the d up. Let's bring the d up. What if I wanted to solve for b? I could bring the b up. Then I could bring the c down. Then I could bring, excuse me, I brought down the fraction. I could bring the b up. I could bring the c down. I could bring the d up. And I've solved for b, etc. Be very good at solving these quick equations. No longer adding and subtracting to both sides, but just simply bringing it over. Because we're going to be doing it with much more complicated equations. And as I said before, with the LCD, we want to be able to do quicker things. We don't want to write as many steps down. I know for so many years they've been telling you, show all your steps. Well, they're going to be going so fast that if you're showing all your steps, you're never going to be able to keep up. So spend a lot of time working with these, make up some questions. Work with them. See if it still works on your calculator. I hope you enjoy the course.